Today I am going to talk about root finding of multivariable nonlinear system by Newton-Raphson method. Here I am going to find out the root of two nonlinear equation by Newton-Raphson method. So here is the problem statement. Find the solution of the system of nonlinear equation using Newton-Raphson method. So here are the two equations. So f1 function 1 x and y, that is x square plus y square minus 4 is equal to 0, and f2 function 2 of xy, that is x square minus y square minus 1 is equal to 0, using an initial guess x0 y0 1 1 and perform two iteration. So here we have to find out the root of the two nonlinear equation, means here we have to find out root x and y. So getting xy, if we plug that, so function will be 0. So that is the root of the equation. So we have to find out. So now here function identification. So here f1 of xy means function 1 is x square plus y square minus 4, and then function 2 x comma y, x square minus y square minus 1. So that is function 2. So before I going to further, so first here what the key equation actually required for finding the root by using Newton-Raphson method. So here is that Newton-Raphson method for the system. So here is the vector form, that xn plus 1 is equal to xn minus j inverse xn into f of xn. So here j inverse xn is nothing but Jacobian matrix, that we can write d dou fy by dou xz, and convergence criteria is the norm of that xn plus 1 minus xn, that is less than the tolerance, that is epsilon. So what is norm? Norm xn plus 1 minus xn is nothing but root of xn plus 1 minus xn whole square plus yn plus 1 minus yn whole square. So we have to find out. So when norm will be less than epsilon, so we have to stop the iteration. So for this problem, function vector, that f of xy, so that is two function we have to write, x square plus y square minus 4, x square minus y square minus 1, and Jacobian matrix, so that we will get from the partial derivatives. So that is df1 by dx, that is 2x, df1 by dy 2y, df2 by dx, sorry, dou x, okay, dou f1 by dou x and dou f1 by dou y, and dou f2 by dou x, that is 2x, and dou f2 by dou y minus 2y. So that is j is nothing but like here dou f1 by dou x, then dou f1 by dou y, and then dou f2 by dou x and dou f2 by dou y. So that is the Jacobian. So here is the Jacobian matrix, 2x 2y 2x minus 2y. And then if I want to find out the inverse of the Jacobian matrix, that is actually requirement here. Okay, so in the Newton-Raphson method, so adjoint j by determinant of j. So determinant is minus 4xy and minus 4xy, that is minus 8xy, and adjoint is minus 2y minus 2y minus 2x and 2x. So that is required to get that inverse of the Jacobian. So after getting that Jacobian here, that j, x and y, okay, so we'll get that 2x minus 2y, 2x minus 2y, so we'll get that, and then apply Newton-Raphson formula. So xn plus 1 and yn plus 1, so that is two variable, that is equal to xn yn minus j inverse xn yn and f1 xn yn and f2 xn yn. Using that we will find out the root of the equation. So here task is determine the solution after two iteration and analyze the convergence. Now using this formula we are going to step by step solution. So for step by solution, so step number 1, first iteration n is equal to 0. So here given x0 y0 is 1 1, so calculate the function value. So f1 of 1 1, so if I plug that, x is equal to 1, y is equal to 1, we'll get minus 2, and similarly function 2, x is equal to 1, y is equal to 1, we'll get minus 1. Then find out the Jacobian. So Jacobian of j of 1 1, so if I plug that from here, this equation, So if I plug that, and that x is equal to 1, y is equal to 1, then we will get here, if I plug that, so that 2 to 2 minus 2. And then if I find out the determinant of the Jacobian, so that is minus 8. And then after that, we have to find the inverse of the Jacobian. So adjoint by determinant of j. So that j inverse will get 1 by 4, 1 by 4, 1 by 4 minus 1 by 4. And then apply Newton-Raphson formula. So here is the Newton-Raphson formula. Okay, so this is Newton-Raphson formula. Xn, x1 and yn is nothing but x0, y0. So it is like that. x1, y1 vectorial form is equal to x0, y0 minus j inverse already here, j inverse of 1, 1, and then multiply of that function value, that f x y means 1 and 1. So that we have to plug here. So this x0, y0 here, then this is the Jacobian, and this is the function value. So after plugging that, we'll get that x1 and y1 is 1.75 and 1.25. Now we have to find the norm, means error. After putting all these value, norm formula is already here. So this is the norm formula, and from using that formula, okay, so we are calculating error. So here error is something 0.791. so it is means if tolerance level is 1 into 10 to the power minus 6 epsilon, okay, so that is not less than epsilon. So go to next step. Okay, then that second iteration, using x1 is equal to 1.75, y1 is equal to 1.25, and then we are going to calculate second iteration, n is equal to 1. Similarly, again we have to calculate f1 at that x1 is equal to this 1.75, y1 is equal to 1.25, we will get 0.625, and f2 will get 0.5. Again we have to calculate Jacobian and then determinant, okay, and then inverse of the Jacobian. After getting that, again apply Newton-Raphson formula, we will get x2, y2, so that is 1.589 and 1.225. and again we have to find the error, mean norms of that. So norms is 0.161. so if you see here, norms is 0.791 and here 0.161, means it is norms, means error is reducing. Now if I go the next step, using x 2 is equal to 1.589 and y2 is equal to 1.225, okay, so we will go for third iteration. So here again using that x2 and y2 value, we have to calculate f1. F1 is nothing but 0.026, f2 is 0.024, and again calculate Jacobian. Plugging that x2 and y2 value, we'll get the Jacobian, then calculate the determinant is minus 15.527, and then again we have to calculate inverse of the Jacobian. After getting inverse of the Jacobian, then we have to use Newton-Raphson formula. So that is x3 y3 is nothing but, so here x3 y3 is nothing but here x2 y2, then minus Jacobian of x2 y2, and then into function of x2 y2. So that if I plug that, so this is nothing but x2 y2, then inverse of Jacobian, then function value. So after plugging that, we will get x3 or y3 is 1.581 and 1.255. Then error we have to calculate. So error you will get 0.008. Okay, though here I have to do the 2 iteration now, but I am going to calculate that iteration 3. So now here error is 0.008. But if I go for the f1 at that x is equal to 1.581 and y is equal to 1.225, so we'll find that the function value is 0.001 and f2 is 0.001 minus 0.1. So here, since both function values are very close to 0, within 0.001, so our approximate is excellent. Means here, as after iteration I am getting here that x is equal to 1.581 and y is equal to 1.225 for this. So function f of x and y, we are getting 0.001, and f2 x y, that is I am getting 0.001. so it is close to 0. So these are my root after 3 iteration. So now if I put in that table of the summary, so here, so if you see here, so at x value 1 1 we have started, then function value -2 -1, then after first iteration we will get 1.750, 1.250, we will get that 0.625, and function 2 value is 0.50, and error is 0.791. then after again iteration number after n is equal to 1, so when n is equal to 2 we are getting x value is 1.589 and 1.225, we will get a function value is 0.026 and f2 value is 0.024, and error is reducing 0.161. and then third iteration, so we'll get 1.581 and 1.225, and here function value is 0.001 and -0.001, and error is 0.008. so after 3 iterations, so it is very close to 0. so root of the equation, root of the nonlinear system of equation, roots, okay, r is like x is equal to 1.581 and y is nothing but 1.225. That's it. Thank you.